Good morning, good afternoon, good evening. Hope you're all well. So today we are going to discuss the seventh problem in the TLE Eliminators CP sheet, 1000 rated problems. The problem name is array merging. So let's start. Let's start by reading the problem statement first. You are given two arrays A and B, both of length n. You will merge these arrays, forming another array C of length 2n. You have to find the maximum length of the subarray consisting of equal values across all arrays C that could be obtained. A merge of two arrays results in an array C composed by successively taking the first element of either array as long as the array is non-empty and removing it. After this step, the element is appended to the back of C. We repeat this operation as long as we can. That is, at least one array is non-empty. We'll be given an n and the elements of A and B arrays. And we need to output the maximum length of the subarray consisting of equal values across all merges. So let's understand what the problem wants to say. So let's take the second test case to understand. We are given two arrays 1, 2, 3 and 4, 5, 6. So this is the A array, this is the B array. So we need to make a C array by taking the elements from A and B. Like if we take this element first, then we can take from this and this. So let's say I take 4 now. So I will get 4 here. Then let's say I take 2 from this. This is also taken. So let's say after this I take 3. So after this array is empty now. Now I can only take from this and this would be the C array, right? So I need to perform this operation and I need to tell what is the maximum length of a subarray that consists of all equal values. Like here there are no equal values. So the maximum length is 1 and that's the answer as well. Now let's take another example. 4, 3, 2, 2, 2, 1, 7, 7, 2, 2, 2, 2, 2. And let's take 7, 7, 8, 2, 2. So this is the example we are taking now. Let's see what we can do. Before we write the array C, let's analyze the two arrays. We are given a lot many 2's in these arrays. So we can think that we can have an answer in 2. So let's suppose we want to build an answer in 2. Let's see. So in these two, I will take the 2. So this one's gone. From these two, I will again take a 2. This one's gone. Now I have 4 and 4. So I don't have any other option. So I'll take 4. Let's suppose I take this 4. Now again I have 3 and 4. I will again take 4. I again take 4. 7, 7, 7. Let's suppose I take this. Then I take this 3. Then I take this 8. Now I can have these 2's. All these 2's and all these 2's. All the 5 2's. Right? 3 from there and 5 from here. Right? So this array is now empty. And after that I can have this whole array. But instead of taking this here, like what I could have done is I could have just taken this and then I could have also taken these. So our array would have contained these both together. So in total I could have gotten 10 2's, whereas right now I have 3 and 5, 8 2's. So one thing that we can note here is that whatever is the maximum length of the continuous segments, like this is a subarray of 2's which contains 5 2's and here it contains 3 2's. So we can combine them from different arrays. Like we cannot combine these and these. There are elements in between. So we cannot combine this and this. However, we can combine this and this. So what we'll do is we will just keep a count of the elements. Like what is the biggest subarray of that count elements. Like in this, we have a subarray of 4 that has a length of 1. We have a subarray of 3 that has a length of 1 again. We have a subarray of 2 that has a maximum length of 5. Not 3 but the 5. I am taking the maximum length. Again I have a 1. Now that has a length of 1. Then 7 that is of length 2. For this I have 2 that has a length of 5. I have 4 that has a length of 2. I have 7 that has a length of 3. I have 8 that has a length of 1. So what I'll do is I will iterate over all the combinations. Like let's say I want to combine the 2's in both the arrays. Like 2 from the 1, 2 from the 2. Like this is from the first array and this is from the second array. Like 2 of A plus 2 of B. So I would like to make this as large as possible. So that would be my answer. Like whatever is the largest, not the 2's but whichever number. Like let's suppose here it was in like instead of 2 it was 9 here, and let's suppose here also we got a 9 that has 3 9s. The length of the subarray that has all 9s was 3. We could have 8 9s. So that could be an answer. So that's all we need to do in this question. So let's see what we are going to do. We are going to have this is what we are going to do. We are going to have a map that shows the maximum length of subarrays that contain X. What do I mean by this? Like whatever is the length. Let's suppose we have in this array and we have many elements. So whatever is the count of 2's, like what is the length of the subarray that only contains 2, and what is the maximum length of that. Let's suppose we have this array. So there are 2 subarrays in which we have 2's. So like in the map we will show 2 has a maximum frequency of 5. So that is what we are going to show. We are not going to show the frequency, but we are going to show the maximum length of the subarray. Like this is the maximum length of the subarray. That's what we are going to do, and then we will just see what is the combination. Like what is the total length of 2 from A's and 2 from B's, what is the maximum length of 3 from A's and 3 from B's. Like we can combine these elements like I showed here. So we can combine the elements. So we'll basically do it for all the elements. So let's see a little bit of code for this. So I'll have my input, that is n. I will input the array ARR and I will input the array BRR. Right, after that I will make a map for int comma int and map2. This would contain my this is the map for this, that would contain the maximum length of subarrays that contain X. Then I will iterate over both the maps and I will have the count, and similarly I will iterate over map2 and have the count. Now instead of doing this, like this is the map approach, we are given one more thing. Like in the constraints we are given that the a of I would be between 2n till 2n. So n can be till 2e5. So 2 into n means 4e5. So we can have this much space. So instead of using a map here, we can use an array of size 2n. Then we don't need 2 loops, but we can have a single loop, like from 0 to the n, 2 into n, and we can have a count. Like this count, that is the maximum answer, and in the end we can just print the answer. So I'll be coding both the techniques now. So let's move on to code the same. So I have my boilerplate code here. We'll be given an n, we'll take it as input, we'll make an array BRR and ARR, we'll take both of them as input. Now I am first using the map approach. Let's include the map library here, map header here. So I'll have a function like calculate maximum subarray, in which I am first going to pass the ARR, MP1 and the n. I am going to repeat the same for the second array. Now I will define this function. It is a void function. Okay, copy void, copy, and we'll be getting a vector and a map. This MP map and the size. So I'll have a count variable that will have like what is the current count and a previous count that I am initializing it with the first element. So I will start from the first element. Now if the current element is equal to the previous, then I will increment the count. Otherwise I am going to add it to the array. Previous is maximum of previous comma the count, and I am going to reset the count to 1 and the previous to the current element. Now in the end also I am going to do this. That makes the map. So now I will have a answer variable that is initially 0, and I will iterate over both the arrays. Now if mp2 dot count of I dot first, that means we have the element in the second subarray, then we can have an answer as maximum of answer comma I dot second plus mp2 of I dot first, like the I dot first, like whatever is the sum of both of the lengths and the maximum of the answer. Otherwise we can just have the answer as max of the answer and I dot second. Like we can also have the current maximum, like whatever is the current length. and I will repeat the same for the second one. In the second, and here the first, here also it is going to be the first, and in the end I will just print out the answer. So let's try it for the sample test cases now. There should be 2125. Yeah, so the code works for the sample test cases. Now let's try to submit it. Submit. And it got accepted. That means our code for the map approach was correct. So let's now try it for the array approach. I will comment this out. Now let's make an array that is ARR count of size 2n plus 1 and assign it to 0. I'll do the same for the second subarray. Now I will again call this function with ARR and ARR count and n. Similarly for the second array, I will make the same function again, and the parameters are the first is the array and the second is the count, array count, and third is the length of the array. So I will just copy this stuff here. So I'll copy the whole stuff now. So this is the same, the count. Instead of the map, we'll have an array count, and instead of this, we'll have this. And here also we'll have the same. That is all that we need to do in this code. Now let's do the calculating the answer part. I'll have an answer variable that I'll assign as 0. Then I will start from 1 and I'll go till 2 into n. Plus. Now answer is max of answer comma the count of I plus the count of I in BRR. In the end, I will just print the answer. Let's try for the sample test cases. 2125. Yes, so it works for the sample test cases. Now let's try to submit it again. And it got accepted. That means both of our solutions were correct. I hope you understood the problem. Comment down what was your approach for solving the same problem. The solution link would be in the description section. Do check it out. Also, this is a playlist for all the problems in the CP sheet. Do check out all the other problems as well. Like the video, subscribe to the channel and share it with your friends. Thank you.